All right, class, tonight's topic is key features of functions. Key features of functions. So key features, first of all, means what are the important features on a graph that we pay attention to. And we're going to be looking at two functions tonight. The first function is linear and quadratic. These should be familiar from Algebra 1. So what I'd like you to do right now is stop this video, pause it, and I want you to write down what you think the key features are for linear and quadratic. Go ahead and pause the video. Okay, welcome back. Let's see what you wrote down, how it compares to what I have. So when you think of linear, did you think of slope? And with quadratic, did you think of a vertex? Y-intercept? X-intercept? Or I should say intercepts, because there could be more than one. Domain and range. With quadratic, you can either have a maximum, which means the vertex is the highest point, or minimum, which means that the vertex is a minimum point. And of course, we can have a domain and range for quadratic. How did you do? I'm sure you did just fine. Okay, let's go ahead and move on. So our objective for this lesson is, given a graph, can you name the key features? Our success criteria, the steps that you need to follow, number one is, first of all, you need to be able to identify the type of function it is. So remember, with a linear function, we have a line. And with a quadratic function, remember, it is a parabola. So you need to be able to identify which type of function it is. Number two, you need to find and list the key features above. So the ones that we just listed above, you need to find them on the graph and list those key features. So those are really the two main success criteria for this lesson. So let's go ahead and take a look at an example. So looking at our graph, success criteria number one. What type of function is it? Go ahead and write it down. You may want to stop the video if you want to draw this function into your graph. That would be a good idea. All right. So it is a quadratic. All right. So now success criteria number two. Name the key features. So we're going to go into depth just a little bit more as we look at these key features in case you've forgotten how to find them. So the first one is the vertex. The vertex is where the graph changes directions. It is either the lowest or highest point. So in this case, the vertex is the lowest point right here. This is the vertex. This is where the graph changes directions. So going from left to right, if we go down, we're going down, we're going down, and at the very bottom we start going up, up, up. So at this point, the graph is neither decreasing nor increasing. It is at the lowest point. Okay? Now, since it is the lowest point at -1, -3, we're going to go ahead and talk about minimum. Because since it is at the lowest point, it is a minimum value, not a maximum. So So it's a minimum because the vertex is the lowest point. And the value, when you talk about a minimum or maximum value, you're talking about the y-coordinate of the vertex. So in this case, the y-coordinate of the vertex is -3. All right, number 4, X-intercepts. Notice I have the S in parentheses, which means there could be more than one. This is where the graph crosses the x-axis. So looking back at the graph, you can see it crosses at 0, 0, and it crosses at -2, 0. These are also called roots. Another name we call them are zeros. And sometimes when we're solving an equation, we're looking for what is x equal, we would call them solutions. But we'll talk more about that later. But you do need to know that x-intercepts are also known as roots and zeros for right now. Okay, there was 2 of those. Next is the y-intercept. Now for a quadratic, there will only be one y-intercept. This is where the graph crosses the y-axis. Okay, so looking back at the graph, it crosses at 0, 0. So make sure you're writing these notes in and that you're pausing the video and getting all of these notes into your notebooks, because I will be checking for completion. Remember, these notes are worth 50% of your assignment grade for our next class period assignment. These must be done. And so continuing on, we're going to go ahead and look at domain, which is the set of all real values of x, okay, that will give you real values for y. So we're looking for all the real values of x in the function. So if you'll notice, this is a continuous graph, which means there's no breaks in it. It's continuous. It goes infinitely to the left because of the arrow. So it's going to -infinity on the left. And on the right, since it's going in a positive direction, it's going to positive infinity. So the domain will be from -infinity to positive infinity, and that's how we get our inequality notation. And then finally, range. Range is the set of all real values of y, go ahead and circle that you can get by plugging in real numbers into x. Remember, when you plug a number into a function, that is the input value, x. The output value is y. Okay, and that represents your range. So in this case, our range are going to be our y values. So down here, we're starting off at -3 on the low end, and it's going up infinitely. So again, we're going up infinitely from -3 on the low end to the high end, positive infinity. Lowest to highest. Remember that from Algebra 1. And domain, left to right. Okay, so I think I will stop you right there for tomorrow. This video just now hitting 9 minutes, so not bad. Make sure you get all these video notes done. I'll see you guys tomorrow. Have a good night.